I've always been curious why the London Tower Bridge, weighing thousands of tons, can open and close like wings. In fact, inside the London Tower Bridge, there is a complex mechanical system hidden. Today I will take you to understand how this bridge actually operates. Let's go back to the 19th century. At that time, London was not a tourist river like it is now, but one of the busiest ports in the world. All kinds of large and small ships and cargo ships crowded here. The problem was that the bridge had to connect both sides, and ships had to pass through the river. So how should the bridge be built? Engineers had many ideas back then, such as sliding bridges. The bridge deck was pulled aside like a drawer, such as a rotating bridge. The middle rotates to let the ship pass. There were also double-deck bridges that could flip up and down. They even thought of using hydraulics to lift the entire bridge. But these solutions were either too complicated, or too inefficient, or were simply unrealistic. Later, they focused on a suspension bridge that seemed simplest. The idea was actually right. Lift both sides. The middle is empty. But after calculating the cost, they found a fatal problem. The bridge deck was too heavy. Even with the strongest equipment at that time, it couldn't be pulled. So the engineers changed their minds. Since it couldn't be pulled, let it balance itself. This is how the Tower Bridge came into being. The Tower Bridge today is not lifted up, but on both sides of the bridge deck, each with a huge counterweight and a hydraulic system to make the entire bridge rotate like a seesaw. You're not lifting it up, but to use the force. The counterweights help you offset most of the weight. The hydraulic system is only responsible for control and drive. The structure of the Tower Bridge is also very special. The bottom of the Tower Bridge is two huge piers, which sit directly on the riverbed, bearing the weight of the entire bridge. Above the piers are two iconic towers and abutments at both ends, which are responsible for transmitting the force back. From an engineering perspective, the Tower Bridge is not a single type of bridge, but also has several characteristics of other bridges. It is a balanced bridge relying on counterweights, and uses steel cables to share the weight of the deck. When it was first built, it was even a cantilever bridge. The weight was mainly borne by the two ends. Later, in the 1960s, engineers added a supporting steel cable to let the overhead walkway participate in the stress. In this way, tension is formed between the towers, making the whole bridge more stable. The real core is hidden inside the piers. This is the balancing chamber, which is reserved for the deck to flip. Only maintenance staff can enter it usually. Going further inside, you will see the engine room. It's like the heart of the whole bridge. The Tower Bridge now uses an electric hydraulic system. There are 4 engine rooms in total, 2 on each side. The reason for this is that the bridge can't stop at any time. Even if one system needs maintenance, the other must be able to take over immediately. But in the earliest days, the Tower Bridge was not so advanced. The power came from the steam hydraulic system. The boiler burned coal to boil water into steam. Steam pushes the huge piston to move back and forth. The piston drives the flywheel to rotate. The flywheel then converts the energy into water pressure. These high-pressure water will be stored in a device called an accumulator. You can think of it as a power bank in a hydraulic system. The greater the water pressure, the higher the accumulator is pushed. When you are by the bridge, you see those buildings that look like small houses are actually used to lift the accumulator. When the bridge needs to be opened, the accumulator relies on its own weight to press the water pressure again. The water is sent through pipes to the hydraulic motors in the pier. The bridge deck starts to rotate slowly. The entire Tower Bridge has 6 accumulators, and each engine room has 2 engines. Even if half of the bridge is broken, the bridge can still be opened. In addition, engineers also designed a high-altitude sidewalk. So even if the bridge opens to let the ship pass, pedestrians on the sidewalk can still walk normally. The city traffic will not be completely interrupted. This design still works to this day. Nowadays, the Tower Bridge still carries over 20,000 vehicles a day. Finally, let's take a look at the process of the Tower Bridge. Before the bridge rises, it will be notified in advance to confirm that there are no emergency vehicles passing. Then the traffic signals on the bridge turn red. The gates close. Pedestrians are evacuated. When the lock pin in the middle of the bridge is fully retracted, the bridge begins to slowly lift. The bridge is slowly lowered after the ship passes. Traffic returns to normal. However, this process was not so precise at the beginning. There was a major accident in 1952. A red double-decker bus rushed into the rising Tower Bridge. and jumped over a gap of about 6 feet, and landed safely miraculously. Although someone was injured, all the passengers survived. Because of this accident, the Tower Bridge's system was made more automated, to ensure that before the bridge deck is completely cleared, the lift will never be activated.